Welcome to Summarize Science, where we break down fascinating research for you. Have you ever played the WikiRace, also known as the Wikipedia game? The rules are simple. Starting from one Wikipedia article, you have to get to a completely different target article just by clicking the hyperlinks. It's a fun challenge, but it's also a serious problem in computer science, representing how we navigate huge networks of information. Researchers recently put different kinds of AI agents to the test to see which strategy is best at playing this game. They created a massive but manageable map using over 100,000 Wikipedia articles and their links. The first type of AI was a structural navigator, which tried to win by finding the most important hub articles, thinking they were shortcuts. Another type was a semantic navigator, which used a powerful language model, or LLM, to understand the meaning of the article titles. This AI didn't care about hubs, it simply chose the link whose title sounded the most similar to the final target. They also tested hybrid models that tried to combine both strategies, along with a baseline random clicker and a human expert. The goal was to see which agent could find the target most efficiently, without getting lost. The results, shown in this table, were absolutely staggering and completely unexpected. The structural AI that focused on finding important hubs failed miserably, with a 0% success rate in some cases. It performed even worse than an agent that just clicked links randomly. This happened because the AI would get drawn to major hubs and become trapped, unable to navigate to a more specific, less important article. But the semantic AI, the one that just followed the meaning of the words, it was a superstar. With a simple rule to avoid going in circles, this purely greedy, semantic-guided AI achieved a perfect 100% success rate. It was also incredibly efficient, finding the path an order of magnitude faster than the other methods. The hybrid models that tried to be clever by mixing strategies actually performed worse, showing the structural signals were more of a distraction than a help. Interestingly, using even bigger and supposedly smarter language models didn't help. In fact, they performed slightly worse on this task. This suggests there's a sweet spot for AI model size when it comes to understanding short phrases like article titles. So, let's recap the most important takeaways from this study. First, when navigating a knowledge network like Wikipedia, understanding the meaning of the content is far more powerful than understanding the network's abstract structure. A simple, greedy strategy of just click the link that sounds closest to the goal is overwhelmingly effective when guided by a modern language model. This simple AI creates a semantic gradient so strong that it can just surf the wave of meaning directly to the target. What does this mean for the future? This research highlights the incredible potential of LLMs to act as semantic navigators in any complex information space. This could lead to smarter search engines or recommendation systems that guide us not by popularity, but by the true meaning and context of what we're looking for. It's a huge step forward in teaching computers not just to follow links, but to understand the journey.